Students, more on distance and displacement. In the previous video, you know what is distance, what is displacement. But question is there, whether they are same. Yes, when the body moves in a straight path. Suppose a body is projected vertically upward. It reaches here. So here distance is equal to displacement. So in this case, distance is equal to displacement. If you take the body moves in this direction, suppose this is the initial point and this is the final point. I mean, body moves in a straight path and in the same direction. If body moves in a straight path, this is the straight path and same direction, then here also distance is equal to displacement. So distance is equal to displacement. But the least value, the minimum value of distance is equal to magnitude of the displacement. I mean, one can write distance greater than equal to magnitude of displacement. Distance greater than equal to magnitude of displacement. So this is the case. What is distance, displacement? When distance is equal to displacement, actually when we solve numericals in kinematics, in more cases you take distance is equal to displacement. Why? Because motion in a straight line or the body moves in a straight line in one direction, and in that case your equation you know in your school, S is equal to ut plus half at square. In this case, S is the distance and also S is the displacement. Okay. So students, now we have to focus on position time graph, because from this position time graph you can get information immediately regarding whether the body is in uniform motion or the body is at constant, I mean at rest, or in non-uniform motion. How to see it? How to find out these, students? I consider graph between this position and time. So suppose I consider this is your this is your time t, this is your position x. So what I consider, you see, I take t is the time, x is the position. So this is position versus time graph. So if the graph is like that, what does it mean? Time is increasing but x is constant. X is not changing. Suppose this point is 40 meter. This is in meter, this is in a second. Suppose this is 40. I mean, in 1 second, x is equal to 40 meter. In 2 seconds, x is equal to 40 meter. In 3 seconds, x is equal to 40 meter. Suppose this is 1 second, this is 2 seconds, this is 3 seconds, this is 4 seconds. So with time, this position is same, constant. I mean, here What does it mean? The body is at rest. So it says about the motion of the body. Here the body is at rest. If I make the graph like this, suppose the graph is like this, what does it mean? With time the position is increasing. You know how to draw graph like this in your previous class, like this. These are the points, you see. These are the points. So I mean the graph is a straight line. What does it mean? With time x is changing, and that gives you what? The body or object is moving with uniform speed. One can say how? Because in this case the body covers equal distance in equal interval of time. Suppose I take x is equal to, suppose I take this is 2t. When t is equal to 0, x is equal to 0. When t is equal to 1, x is equal to 2. When t is equal to 2, x is equal to 4. When t is equal to 3, x is equal to 6. So if you draw graph for this is like that. Or one says, sir, we take x is equal to t. Yes, the graph will also be like that. X is equal to 3t, x is equal to 4t. If you consider whether this is x is equal to some constant into t, I mean if x is equal to some constant into t, the graph is a straight line passing through the origin. This indicates that this is the uniform motion of an object. But if the graph is like that, you see what does it mean? Suppose this is T1, this is T2 like this. What is the significance of this graph? You see, from origin to T1, the position is increasing, but not with a constant rate. I mean here, equal distance in equal interval of time is not possible. I mean here, unequal distance covered in equal interval of time up to what? T1. So that's why the graph is like this. But from this point, this is a straight, like that. Straight. So from this to that, it is a straight path. So this gives you uniform motion of the body. So from T1 to T2, with time, its distance is increasing at a constant rate. I mean, equal distance in equal interval of time means the body moves from time T1 to T2 with uniform rate. After T2 time, the body or the object what? Comes to rest. How? Because you see, after time T2, the graph is like this, means this position is constant. Here with time, but position is constant. So one says, you start your motion from this origin. For this time T1, your speed is increasing, but from this to that, the speed is increasing at a constant, the speed is constant. From T1 to T2, your speed is constant. From this to that, or time this to that, your speed is constant, then the body comes to rest. You start your motion from your home, you gear up and your speed increases up to certain time, then speed remains constant, then you have applied brake, what happens? The cycle or your bike or motorcycle comes to rest. This is the case. I think you understand the graph, and very important from this graph or position time graph, your speed is obtained or velocity is obtained. How? If you take slope, how to find out slope? Any two positions, suppose here is a position, here is a position you take, you join this, so this is a right angle triangle. In this right angle triangle, suppose this is A, B, C, this angle is theta I take. So in this case, your tan theta, how much? You will get tan theta is equal to what? AB divided by BC. This AB is nothing but change in position, because this is parallel to this. So this is what? Change in position. This is what? Change in time. T1, T2, that is change in time. So that is what? Change in time. This change in position by change in time, nothing but your velocity, or what you say, speed. So I mean, from this graph, if you take slope, you will get velocity or speed. Okay, thank you.